So our first section that we started off with is trig equations with radians. I'm going to screenshot this. And then we're going to solve the trigonometric equation for all values between 0 and 2 pi. So solve it for all values inside our circle. So when you want to solve this, you just want to get the cosine x by itself. So that's what we're going to do. So I'm going to start by adding 1 to both sides. We'll get 2 cosine squared x equals, because those cancel out, equals 1. And then we're going to divide both sides by 2 to get the cosine squared by itself. I'm going to write it over here now. The 2's cancel out. We will be left with cosine squared x equals 1/2. Before I go on, are there any questions? Okay, if there are, remember that you can interrupt me at any time. I have a chat pulled up on my computer, so just type it there if you have anything. And then from here, we're going to want to square root to get cosine x by itself. We will get cosine x is equal to the square root of 1/2. But I'm going to do it like this, square root of 1 over square root of 2. I'm going to separate it out. Okay, any questions up till here? Alrighty. Remember again, if you have any questions, we can just shout it out or type it in the chat. So we need to simplify this until it's something we can recognize on the unit circle. So we have square root of 1 on the top is just 1. And then on the bottom, we have radical 2. And then this is not a proper fraction. We need to multiply it by radical 2 over radical 2 because we don't want radicals on the denominator. So you want to make sure you have radicals on the numerator, not the denominator of your fraction. So let's rewrite that. So we got cosine x is equal to radical 2 on the top over radical 2 times radical 2 is just radical 2 squared, which gives you a 2. Okay, so from here, this is one of the things we can look for on our unit circle. I'm trying to zoom out. There we go. So cosine x is equal to radical 2 over 2. So on the unit circle, remember that cosine is the x value. And then sine is the y value. Also remember that tangent is y over x. So sine over cosine. So in our case, we are looking for the x value because we are looking for a cosine. Right? We're looking for cosine, so we're going to look for the x value to be that thing. And I see that, oops, that kind of covers it. But I see it over here and over here. And so, since I see it over there, then our answers, I guess I can circle it in red, would be the radians pi over 4 and the radian of 7 pi over 4. Okay, any questions up until here? Okay, so I'm going to go backwards a little bit, and I'm going to refer us back to our work that we did over here. When we did our square root, we square rooted the 1/2 to get radical 1 over radical 2. And we did the square root because we wanted to turn our cosine squared into cosine x, right? So we did a square root there. When you solve things and you do a square root, you can get two answers. Like, let me show you in numbers. If I say square root of 9, you can get positive or negative 3, right? So then we have another set of answers coming out here. We could say or negative radical 1 over radical 2. So we have the positive one that we just did, which is in black. And then another set of answers can be given to us with this thing that I just wrote over here in red. Because when you square root it, you can get the positive or the negative. The first time around, I did it with the positives. Now I'm also showing you the negatives. Because when you square root something, you can get the positive number or a negative number. Any questions on that part before we continue? Okay, so from here, we still need to do the multiplying by radical 2 over radical 2. And then so this would give us, I'm going to just write it on this side because it's where I have space. This would give us negative radical 2 over 2. So let's also look for when cosine is negative radical 2 over 2. So where can we find negative radical 2 over 2 as our cosine? Cosine's the x value, so I see that over here. And over here, I see negative radical 2 over 2, which makes our, what's it called? Radians, 3 pi over 4 and 5 pi over 4 as well. Okay, I'm going to pause recording for a second to give you guys a chance to ask questions. All right, let's go enter these in. So I'm going to do that so I can enter all 4 of those. I believe they were pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay. All right. So as you can see, all 4 of those, I know that's a lot, right? But yes, all 4 of those were your answers. I want to do another one with you guys. So we got a cotangent. I'm going to screenshot this. Okay. So we have cotangent x minus 1 equals 0. The equation itself is more basic, but we have a cotangent here, so we got to remind ourselves what all of those equal. You know what? I'm going to write it on the top here for you, just in case, because I feel like it might be buried deep in your notes, and so I want you to have it more like on the forefront. So I want to remind you that sine is the y value, cosine is the x value, tangent is the y over x, and then here's the reciprocals. Reciprocal of sine is cosecant, so cosecant is 1 over y. Reciprocal of cosine is secant, so that's going to be 1 over x. And then reciprocal of tangent is cotangent, so that would be x over y. So here's just a little refresher for what you're looking for in the unit circle when we get there. But yeah, I'll leave that right there so you can still copy it just in case you don't remember it. And we're going to deal with this equation. Cotangent of x minus 1 equals 0. So we're going to add 1 to both sides so we can get the trig equation by itself. So we have cotangent equals 1. So we're going to look for when our, remember that cotangent, I'm just going to highlight it. Cotangent is x over y. We're going to look for when the x over y is equal to 1. X over y, because that's cotangent, equal 1. So we have to ask ourselves that. Okay, so then you just have to remember that x over y, x divided by y can only equal when this happens when x equals y. It can only happen when your x and the y value are exactly the same. Do you guys have any questions on that? I know that tangent and cotangent are one of the trickier ones because you just have to like think about when does this happen? You can't just like look and see it, you know? So cotangent and tangent are trickier. So when does x equal y? This happens on our unit circle. I'm trying to zoom out. In only two spots. Right over here, when your x and your y are both negative radical 2 over 2, and over here, when your x and the y are both positive radical 2 over 2. Some of you might be wondering, what about these places? What about these? Because they're radical 2 over 2 and negative radical 2 over 2. Well, no. So if this was cotangent, you are dividing them, these would have a cotangent of -1. So these would not be part of your answers. Just in case any of you were wondering, would those be qualified as well? No, because those would have cotangent being -1. So only these, with the circled green, would have cotangent equal to +1. So our answers would be those radians, 5 pi over 4 and pi over 4. Do you guys have any questions? I'll pause the video to give you guys more time to think about your questions. All right, so I'm going to enter in pi over 4 and 5 pi over 4. Okay, let's do one more, just because I think maybe some of you need 3 examples, and if not, it's totally fine. You're probably already working on it on your own anyways, so I don't have to worry about you if you don't need this example. So for those who do want the example, we have a secant over here. So we want to get the secant by itself. So let's get the secant by itself. Oops, I don't want to use red. We're going to add 2 on both sides. So we got radical 3 secant x is equal to 2. And then divide by radical 3, divide by radical 3. I'm going to write our answer on the side here, or continue it on the side. Then we're going to get those canceling out. Secant x is equal to 2 over radical 3. And so then, remember that secant is the reciprocal of cosine. So if you flip this around, and I'm going to show that with a flippy arrow like that, we'll get cosine. We'll get cosine. Sometimes it doesn't write. And then we're going to flip this around. So instead of 2 over radical 3, we can get radical 3 over 2. So all I did here was I flipped the secant to get cosine, because they are reciprocals, and then I flipped the 2 over radical 3 to get radical 3 over 2. Any questions over here? I do realize I wrote a theta next to cosine. Technically, it was an x, so I'm going to fix that. Okay, so yeah, cosine of x is equal to radical 3 over 2. Doesn't look like you guys have a question, but if you do, just remember to interrupt me. And so remember that according to the chart I wrote earlier, cosines have to be x values. So we're going to look for x value on unit circle to be equal to radical 3 over 2. So let's go look for that. Where on our unit circle can we find the x value to be radical 3 over 2? And I see that right here and right here. And so we are going to have this, oops, you know what, whatever, that's fine. That and that as our radian answers. Any questions? Okay, let's enter pi over 6 and 11 pi over 6. Okay, so that was this section. Let's go back and do another recording for the other section.